So I'm Daniel Terdiman from Fast Company, and this is Melonee Wise and Michael Buckwald from Fetch Robotics and Leap Motion. And maybe you guys could just start off with just a brief description of what each of your companies do, so for the folks that aren't familiar.
Yeah, so we're focused on tracking hands and fingers and bringing that to all of technology, so that interacting with computers, whether it's a virtual reality display, a PC, a HUD in a car, that's as natural as picking up a coffee cup and taking a drink of it in the real world.
And Fetch Robotics basically builds autonomous and collaborative solutions for the logistics market. What does that really mean? We build robots that transport goods within a facility from point A to point B, and we do it in all sizes, so pieces, cases, and pallets. And it increases efficiency within the facility.
So when I first saw the topic for this panel and who I was going to be moderating, I was kind of curious, like, do you think that there's some connective tissue between what you do and what you do? I mean, and if so, what do you think that would be?
Yeah, I think that robots, as they evolve, we're always going to need new ways to control and interface with these machines. And definitely the sensor technology and the software that Leap Motion provides could definitely potentially be a player for increasing, the fidelity of the motion control that we can do with robotics. But, there's a lot of different modalities for controlling robots already today.
Mm-hmm.
Yeah, and I think that robots suffer from the same problem that all of technology does, which I think is the fact that computers, in an absolute sense, and the power and ubiquity of computers has increased in unfathomable ways over the last 30 years, but at the same time, input has really lagged behind it. And now we have, every person here probably has a phone that is as powerful as whole city blocks full of supercomputers would have been 30 years ago. But the ways we talk to our machines and technology, whether it's a robot or a computer, are still pretty simplistic. It's, am I touching or am I not touching? Am I pushing that button, not pushing the button? And that really holds technology back, I think. And in the case of a robot or a computer, if you can bring something like hands into that, and if you can take advantage of the fact that every single person who is alive already knows how to do certain very complicated things that for us are just a instantaneous part of our fundamental human nature, then you can perhaps for the first time in a long time bridge that gap. And by bridging that gap, exponentially increase the amount of things that people as a whole, whether it's advanced industrial users with powerful industrial robots or everyday people at home trying to teach their kids better, what they can do with technology as a whole.
Right. So what are some ways that you feel like your products are sort of fundamentally transforming the industries that you work in?
Yeah, so if you look at what we do at Fetch, since we are in the logistics industry, we're basically creating flexibility. We're enabling companies and small companies, large companies to create flexible infrastructure. If you look at what's been happening, consumers are really changing the way they purchase goods. It used to be you would bulk your orders and wait for it for 5 days and then you'd get it. And now you can get it in 30 minutes. So that really changes how we need to get goods from the shelf to the box. And the workflows are changing and we need to be more flexible. People are building distribution centers on the back of Walmarts and Targets. And so providing flexible autonomous systems in those environments is key to enabling that kind of infrastructure.
So how do your robots achieve that?
Yeah, so if you look at our robots, when they're deployed in these settings, they can increase the efficiency of an operation between 30 and 50%. And we can deploy a system in 8 hours, so it's very lightweight, it's easy to get started, it's easy to get going, and all of it is kind of plug and play because most of our software runs in AWS instance for doing the fleet management. So you come in, put robots on Wi-Fi, and they're already connected, and they can start doing work immediately.
Got it. And Michael, what about you?
Yeah, so we think that right now a lot of new technology like virtual reality and augmented reality and robots is being held back by input and by the fact that the fundamental premise of these technologies, especially things like VR, is that you put on a headset and you feel like you're actually in a place. And emotionally, I should feel like when I put on this headset, I am suddenly transported to another world and another universe. And I think right now, you don't feel that if you're fiddling around with a controller that you haven't used before. And at the same time, if you see your hands there and you can interact with it, and not only can I instantly figure out how to use it, but like a 90-year-old grandmother from China could walk up and see her hands and instantly figure out how to use those hands to do things as well, then not only do you have an opportunity to have a massive sense of presence, which is, I think, the fundamental product goal of virtual reality, but also you can increase the amount of things people can do in VR massively versus the current input modalities, which are, at the crudest form for mobile VR, things like tapping your head, and at the sort of most sophisticated without hands, something like a controller. But I think none of those is sufficient to replicate the full dexterity of human presence, which I think has to be the goal.
Right. And so when Leap Motion started, you were not thinking about VR as sort of your application. Like, what led you to get to that point?
Yeah, we always knew that the best use case would be some combination of 3D input and 3D output. And at the time, we weren't sure exactly if in a few years that would be like holographic displays or better like auto-stereoscopic screens or something like VR or AR. And we were always thinking about, like, philosophically and from a vision perspective, what the tracking would have to evolve to work for that world. And we were consistently pushing out software updates to improve it in that direction over the last X years. But I think as we've seen VR mature, and as we've seen AR mature, and as we've seen billions of dollars going into these spaces, now it feels like there is an opportunity because I think that the hardware itself is more than mature enough to deliver these experiences, and what's missing now is first input, which I think you get through hands, and then the types of content, whether it's the operating system being rethought in a way to take advantage of this, or actual content, whether it's industrial or commercial, or games being built around this. And I think once all of those things come together, which will probably happen in the fourth quarter of this year or the first quarter of next year, I think we'll see hopefully an exponential transformation akin to the iPhone in this space that I think will kind of set the space on fire in a way that we haven't seen with the very first generation of VR.
So Melanie, how do you see VR and robotics working together? Like, can you see VR being a good front end for sort of robots that are working autonomously inside a factory or something like that?
Yeah, I would say that so far the technology isn't there. I mean, VR in robotics is kind of a disaster. When you put a headset on and then you try and use a hand-based control interface, the problem is that the mapping for a robotic arm to the physical joints that we have is actually a poor mimicry, because robot arms have continuous joints. They can do things that people can't. So if you want to pick up a screwdriver and then screw something in, we go like this. But if you do it with a robot, the robot can just go, and that's something that doesn't translate biologically. And so there's actually a lot of limitations with trying to model haptic interfaces and interfaces after our own biology on these mechanical systems. And so there is a place for it. I mean, surgeons use it with the Da Vinci robot to do surgery. They actually have stereoscopic vision, and they can see into the body and perform very intricate surgeries with basically finger haptic controlled devices. It's like a little glove that you put on your hand. And it's very sophisticated. It can do very interesting things, but I think that when we look at how we want to do control for robotics, we need to step out of this human perspective and start thinking about how we can build tool sets that extend the experience beyond what we know. I mean, it's good and easy for video games and things like that, but when you're a teleoperator trying to make something happen, like a bomb disposal and things like that, actually what we start doing is we start doing what's called assisted autonomy. So you do a teleoperation move, and actually what you do is in the 3D image you say, I want to pick that up, and all of the robotics does is all the motion planning, and it picks it up. You don't actually do that manipulation. That makes no sense. All of this autonomy, all of this intelligence is there to assist you. So why would you actually physically teleoperate? You do assisted teleoperation.
Right. So I mean, you've been a leader in robotics for a long time. Like, what's the future look like that in 5 years? Where we're going to be for this sort of like input and manipulation?
Yeah. So a lot of people have developed some very sophisticated interfaces for doing assisted teleoperation. I think the biggest challenge we have now is that making them easily usable and putting them into, I guess, browser technology in many ways, because that's what people are comfortable with. It also with the browser technology and stuff like that, it makes it a little bit less bandwidth heavy, because a lot of right now, when you look at the teleoperation interfaces, you're streaming live point cloud data, which is like a three-dimensional view of something, into a visualization, and that can be hundreds of megabytes per second. And that's not really realistic. And if you look at, I don't know if you know about the DARPA Robotics Challenge, but one of the things they did is they simulated what it's like to teleoperate something remotely with a really crappy internet connection.
Yeah.
And those are the things that we actually have to overcome with this teleoperation, virtual reality, augmented reality kind of thing. And if you look at what most of the modalities for doing the DARPA Robotics Challenge was, it was all centered around assistive teleop and actually creating algorithmic assistance for teleoperation, whether it's a controller, whether it was a haptic device, and giving feedback, because that's the other big important thing when looking at teleoperation, is how do you get physical feedback to the user? Because we as people struggle very much with, if I grab something virtually and I can't feel it, then I can't actually execute that virtual action. Right.
So I want to get to VR more in a sec, but since you mentioned the DARPA Robotics Challenge, and then there's this sort of idea that that's in the mainstream, that robots are gonna take our jobs. But like, I was at the DARPA Robotics Challenge, and I remember seeing these gigantic, super advanced robots standing at a door for like 10 minutes with their arm out trying to figure out how to open the door. And I just thought, this does not seem like something that's going to take anybody's job anytime soon. So I know that you don't really buy into that argument. Like, what's your thought on that?
Yeah, I think it's complicated, because the DARPA Robotics Challenge was trying to do something with hardware that was like at the edge of the edge of the edge of cutting edge. I mean, the robots that you saw, most of them cost $2 to $5 million. Right. So, they were huge, massive invested machines, and a lot of the challenge with that event is there was actually a lot of really incredible research that happened there. And I think there's a point right now where we're able to do things in structured environments. We're able to deploy these robots in useful business cases, but making the leap from, okay, I'm going to assist someone in a warehouse, to I'm going to go into Fukushima and stop a nuclear reactor from melting down. The bridge is long and far, and we have a long way to go.
Got it. Michael, talking about VR a little bit, like, I write about VR as a consumer application, but there's a lot of like enterprise applications for it. Like, what are some of the industries that you think are sort of most ripe for being transformed by and disrupted by VR, outside of consumer and gaming?
Yeah, I think there are many, and I think in a lot of ways some of the industrial and commercial use cases are actually more mature than the consumers, since the industrial users will buy a device just to use it once. And I think everything from, in healthcare, we see people trying to have a better understanding of like physical therapy and compliance, and give people feedback about how someone's grasp is improving at a sub-millimeter level in real time, and to overcome what is the biggest challenge to compliance, and which is just a lack of progress that's visible for weeks or months often. We see advanced simulation and training. Like the Australian mining regulator is using VR and leap motion hand tracking to perform the federally required training that coal miners have to go through in Australia as part of that. I think one that we're very passionate about is education, because I think it's very clear that there is a fundamentally different way that we cognitively develop ourselves when we learn things in a physical way. And I think, for example, any person here probably has a very specific idea of what will happen if you throw a ball and how it will arc and such, and that's from childhood, and that stays with us for the rest of our lives, even if we never learn how to like write out that equation. And yet, we don't have a lot of other ways of trying to build ourselves cognitively and learn about more complex things. Can we teach children about complex economic theory by building a 3D representation of it and having them build the same physical intuition for it, or quantum particles, or can we teach doctors or researchers better in that way? Can we take huge data sets that we're collecting about everything in the world and visualize them in 3D and bring that incredible human intuition, which it seems like in a lot of cases is actually superior to a intellectual knowledge. Like Tony Hawk is a better skateboarder than the best physics PhDs who have the best understanding of the equations that represent the actions that he's doing. And yet still he's much, much better than they are at skateboarding, which speaks to the power perhaps of this deeply fundamental human intuition being brought to bear on all sorts of things that right now we just don't have the fundamental mechanics to create these constructs around.
Got it. Okay, so I've seen all these analysis of the markets that say that augmented reality could be 4 times the size of the market of virtual reality, and I'm wondering if that's something that you buy, and if so, why?
I think so. I think that both VR and AR will be very successful. I think that at their best, they are very different things. I think VR at its best is radical immersion, where you are wearing something that's opaque and you can't see the world around you, and that's okay because you want to feel like you are in a different place than you are. And I think that there are a lot of applications all across the spectrum where people will want to do that. Whether it's putting on a headset and feeling like you're inside an ultrasound if you're a medical professional, or if it's a game if you're a person. And I think that it can be a big, big industry still, many, many billions of dollars, and very important. But I think that at its best, AR, which I think has a higher technological threshold, and on one hand, there's now billions of dollars that are being invested in the space, which is good. But I think that for it to be a mainstream consumer phenomena, which is where I think that the outsized potential happens, I think that we'll see much earlier people who are concerned about aesthetics, like doctors and professionals and such, doing really impressive things with augmented reality much earlier. But I think for consumers, it's going to have to be the coolest pair of eyeglasses in the world for people to wear it all the time, and at the same time be able to project almost physically indistinguishable things around your field of view, so that I can look over there, and instead of seeing you, I could see a giant orc if I'm playing a video game, or I could see a character from Lord of the Rings if I'm watching a movie, or if we're interacting as workers, I could see you there for telepresence.
Right.
Or also just the idea that if we're friends in real life, I can see you exactly as I see you now in person, but without actually having to travel all over the world. So there's huge, I think, AR has the potential to replace everything we know in terms of our consumer electronics and such, but there's a lot of unknowns and a lot of technological barriers to get there. But I think that at the end state, both of these things, if you can deliver the emotion that they promise, I think they will be phenomenally successful.
Got it. Let's talk about projection. I mean, you were telling me something yesterday, Melanie, about putting a projector potentially on top of one of your robots. Can you talk about that just sort of briefly in our remaining time?
Yeah, I think that if you look at augmented reality, it has a lot of power, and one of the things is you can actually create augmented reality without having a headset on. And so when we look at how we would assist a picker in a warehouse, the robot can actually drive to a location and do the image rectification onto the scene to say, this is the box you pick. Because if you look at the picking activity, like 15% of their time is wasted just searching.
Right.
And so the robot could use a projector and a 3D time-of-flight camera to basically rectify the image onto a set of boxes and light it up. And
Just make it faster and more efficient.
yeah, it's like playing whack-a-mole, you know.
Nice. Well, we are out of time, so thank you very much for joining us here on stage, and thanks you all for sticking around.
Thank you.
Thank you very much.